Okay, now we're going to record the last part for homework 4, part C. And for this part, we have to explain the geometric rationale for Lagrange multipliers and use it in conjunction with Broyden's method to find the minimum of the 2D Rosenbrock function constrained to a circle center at 1, 1 with a radius of 0.5. Okay, so let's go back to this. And the first thing we're going to do is hashtag import necessary, libraries. And so first, import numpy as np. I have to import jax dot config dot update jax underscore enable x64 and there has to be an apostrophes and then true. There. Then import jax dot numpy as jnp from plotly dot subplots import subplots from ID optimize import minimize. Hit enter. I think I did that correctly, but I'm not really sure about the jax config update. But it seems like it worked. So then the next part of this is to define Broyden. So def Broyden. And then after Broyden, we have to put max iteration, which is 100 iterations, tolerance. Okay, now we've defined the Broyden with our variables. Sure. Now we're going to do the initial evaluation of the function and its f val 1 is equal to f. And then 1 ignore jnp dot win ouch no 1 and I'll go parentheses close. And now we want to initialize the Jacobian approximation as the identity matrix. And I will type it out. So we want to initialize the Jacobian as the identity matrix. Okay. AI equals x1 size and now we're going to do the main iteration for range max iter and now we're going to compute the step using the current Jacobian approximation. Dx equals JIV at f val one, so that is dot product or vector. Yeah, dot product. There we go. I'm going to line search to find step size reduces function value, and that should be on the last one to describe what it is. Okay. For J, then it's 2 equals dx. 2 f is 2. Now that's value 2. Just norm. Dot norm f val 2. Okay. Now we're going to check if the function value is smaller than the previous value. F val 2 underscore north is less than 1 underscore north. Great. We need to get out of this in backspace. EX does not equal 2. And this will reduce the step size. I don't enter backspace print iteration and verbiage. So it's print iteration information, and so now we're going to say print norm. Okay. And we're going to check if the norm of the function value is below our tolerance. Okay. J and P dot norm is less than FL2 actually. Then is less than tolerance. Great. Now we want to reshape our vectors for further computation. Now dx equals dx. That reshape. No. Oh. One. Reshape. Now we want to update the Jacobian approximation using the Croydon update formula JINV plus the vector multiplication at dx dot t JINV dx dot t and ji at df, and those are your dot multiplication vector. Oops, I didn't need that second one. Enter Now we're going to update the current solution and value. X1 is equal to X2. Oops. X value 1 is equal to X value 2. Now we're going to return X2. Now we're going to see if it works. There is something wrong. Dx does not equal 2 and it does not match. So that means that I have to bring it out. I think it's supposed to go here though. Let's see. How about now? Uh-oh, now my break outside of my loop. Tab over, it should be in there. Tab over, it should be in there. Shift enter. Okay, so I did some tabbing over to make sure that everything was in the right spot. The break is now fixed. Now I just have to figure out where this return belongs. And it's right there. Now everything works. Now we can move on to the next part. We're going to do our Rosenbrock function using V. So now we want to unpack the variables X and Y equals B. And now to compute the Rosenbrock function value. Result equals 1 minus X. 2 squared plus 100 minus Y X. Oops. Return result. And let's see if that works. It works. Now we're going to define our constraint function. So, yep. Constraint V. And then we're going to unpack the variable X and Y again. So X comma Y is equal to V. Now we're going to compute the constraint function value, same as before. Oops. X equals 1, 2 plus 1 minus 0 minus 0.5. Return our result. Shift enter this, and that's our 1 and 1 from earlier. So, circle center at 1 and 1, the radius of 0.5, and that's what that means. Now we're going to do initial optimization. Yes. So for this, X guess. Ready. Then now we're going to minimize Rosenbrock function. And this is going to be subject to our equality constraint. Okay. Minimize Rosen X guess frames equals C, and then we want to type equals EQ function equals constraint. Okay. Okay, it worked. And so you see down here, you get a message optimization terminated successfully, success true, status 0, function, you get this number. Now we're going to define Lagrange. Use value, and then now we're going to extract the, I'm just going to say L, multiplier. L equals B. And now Lagrange value, sum of the rows function. And product of L constraint function. So our result equals Rosen, okay. B2 L times the constraint, and then B2 turn result for us, and now we're going to check to see if it works. It works. Oops, let's do an E. Okay. Now we're going to say Lagrange underscore Jacobian is equal to Jack's Jacobian with the Lagrange. Yes, and then now we're going to shift enter and it Croydon and then Lagrange Jacobian. Yes. And let's see if this comes out to the 0.75. It should be. Oops. Shift enter, not enter. Ooh, let's see. R class is not cool. Right in parentheses, Lagrange underscore Jacobian or Jack. Then JMP. Did I nope, this one's space. JMP.R. Maybe brackets instead of parentheses. Let's see. I got a 0.5, 0.25. X val 2 is not defined. Where's this? Shouldn't be an X. Oh, my meeting will end in 10 minutes. Okay, so X val 2 is not defined. This is X equal X1 equals X2, X val 1 equals X val 2. You know what? It should be F val 2. See, like up here. So where did I put that? Wait, no. Trying to find it. Of course, I'm this way. Am I blind? I am. This actually, here it is. F val 2. I don't know why I thought it was going to be anything else. Okay, so let's shift enter, shift enter, shift enter, shift enter, shift enter, shift enter, shift enter. And my head hurts, so I hope this works. Yay, 0.75. I can't read. And my head hurts, and I'm going to sleep. Good night. Thank you.